happy Wednesday. It's hump day of Warrior Week. Woohoo! Yay! All right. So yesterday we were talking about the A value in our wonderfulness that is y equals A B x minus C plus D. Okay? So either sine or cosine is what we're dealing with here on that one. Okay? And so we talked about A yesterday. Okay? A was the amplitude. That was our vertical stretch. Okay? It adjusted our high, it adjusted our low, it adjusted the range, okay, kind of those things. A is always positive because it's a distance, okay, all that fun stuff from yesterday. Okay? Today, or actually, so what we're going to do to start here is I would like you to do this one as a warm-up, and we will always be graphing one period. Okay, so we'll graph a first lap wave is what I want you to do. Okay? So if you could graph -3/2 sine x, please. Domain. All real numbers. Always going to be all real numbers as long as we're dealing with sines and cosines. Love it. Middle. 0. Okay, so that's going to be where we start. Amplitude. 3/2. Yep. So that means my high value is going to be 3/2. My low value is going to be -3/2. And so then my range, -3/2, comma, +3/2. Love it. Start. 0 and 2 high, period. 2 high. Love it. Okay. Negative sine value. So actually, tap the brakes here, Linz. Got a little ahead of yourself. Sine. Where does sine start? Starts in the middle, and then normally it would go up, middle, down, back to the middle, right? But because we have a negative A value, we're still going to start in the middle, but we're going to go down first, right? Okay? So we're going to start middle, go down, come back up, and in the middle. Okay? So then we can fill in our -3/2, +3/2, and 0. 0, pi/2, pi, 3pi/2, and agree? Love it. Love it. Okay. So that was amplitude A. Okay. So now, today, we are going to talk about B. Okay? So B is going to set the period. Okay? How long it takes you to make one complete wave. Okay? That's what? Yeah.
I would also like to say, my homeroom teacher thought of the extended homeroom today.
Oh.
So we all just got let out now.
Okay, that's fine. I'm not bad. Okay. So it sets the period. Okay. So that's how long it takes you to get one complete wave. So obviously B would adjust in our pieces of 9. B would have control. I forgot the R in control. Over the period, obviously, and the end. And I think that's pretty much it. Okay? That would have control over. Okay? The start is actually going to be controlled by C, and we'll get to that. I believe we're getting to that tomorrow. Okay? So for right now, we're still going to start at 0. We're just not going to end all the time at 2 pi. Okay? So that's what B controls. Okay? It sets the period. All right? So, you guys don't have a graphing calculator, but if you have your Chromebooks with you, or if you do have a graphing calculator with you, okay, get those out, because if you are on a, if you can always use Desmos, okay. The handheld calculators would be a lot quicker, but Desmos would still work here. Okay? So this first one we don't have to, or I already did for you. Okay? So we graphed it using a graphing calculator on a specific window. Our window went from 0 to 2 pi, and it went. The only reason we went to -2 was so we could see the full curve. Okay? But it should only go to 1. Okay? So this black one here, this is my normal sine first lap wave. Okay? Starts in the middle, goes up, back to the middle, goes down, back to the middle. Okay? Now if I add in this -1/2 here, right there, then I get this is my curve. And it actually would start in the middle still, but it goes up, comes back down, and then if we would continue this, it would go down and it would come back up, and it would come way back up over here at 4 pi. Okay? And that would give me a full, complete wave, first lap wave. So, what I would like you to do now on Desmos or on your graphing calculator is I would like you to explore these 5. I guess there's only 5 there. Let me grab a Desmos here because there's some guys at home. Oops, that wasn't supposed to do that. Not a fan of this setup. That one. Almost grab the calculator. Okay. So on Desmos, you need to. There is a wrench right up here. The wrench is your graphing settings. Okay? So on this, you would want to go from 0 on your x-axis, and this goes for your graphing calculators also. You would want to go from 0 out to, let's say, 2 pi, but you would adjust this here. On calculators, I know there's a pi thing, but I don't know if there's a 2 pi on this one, so we'd have to go like 6.28, we'll say. We'll go 3.14 for keyboard bottom left. Oh, down there?
Yeah.
2, and then, so this thing down here?
Yeah, I want to tell you. Right by the.
Got it. Right there. Awesome. What's this right here stuff? I don't know what that is. Okay. and then you can graph it like that. Okay? Love it. So graph those and find me some periods. See what you think you can find for the periods. Okay? All right, so I got in red, I've got cosine of 2x, which is what we had, and in, I guess it's in red also. That didn't help. But so there's cosine of regular cosine, right? Okay. So it has a period of 2 pi, right? So let's put that one over here. Actually, we'll put it in red because it's in, whoa, now where did that go? Oh, wait. Guess I can't do that. Okay. So cosine has a period of 2 pi. Love it. Okay. So cosine of 2x now, how many laps or how many waves did we go in 2 pi? We went 2. So what would the period be of cosine of 2x? No. Nope. Because we made 2 waves in that time. Draw right on top. Nope, I can't draw right on top. Wish we could draw right on top, but can't. Okay? So it made, here's 1 wave, right? How long did it take me to go 1 wave? Pi, right? So the period of cosine of 2x is pi. Because that's how long it took me to go 1 complete wave. Because it takes me 2 pi to go 1 complete wave on regular cosine. With me?
Wait, can you put the cosine to x?
So it started on high, right? Cosine starts on high, and I'm done when I'm back up at the high point, right? So I started at 0, went down, came back up, and I ended, so 1 lap would be at pi. Okay? Cosine of 1/3 x. Looks like that. Get rid of that one now. Did we find, so we start on high, right? So we gotta scroll out until we get back to high. We're back at the high point at 6 pi. So the period of this one, or of cosine of 1/3 x, is 6 pi. Now I gotta get back. There. Okay. Sine of 3x. Sine starts in the middle. So sine, regular sine is the blue curve here that you see now. Starts in the middle, goes high, comes back to low. Well, sine of 3x makes how many waves in 2 pi? How many complete waves are made by sine of 3x in that viewing window that you see on the front board? So it makes 3 complete waves, right? Middle to middle, 1 to middle 2, the middle, 3, right? Okay, so if it makes 3 waves in the span of 2 pi, how long does it take to make 1 wave? Okay, what can we say that even easier? 1/3 of 2 pi. 2 pi over 3. Hmm? Okay. Sine of 4x. How many complete waves did we do in 2 pi? 4 complete waves. So if I did 4 complete waves in 2 pi, horizontal distance, how long did it take me to do 1 wave? 1/4 of 2 pi, right?
Oh shoot, not the math again. I don't.
Pi over 2. And lastly, cosine of 1/5 pi. Make 1 complete wave. We got to go all the way out to 10 pi, right? Yeah. Now, what happens if b is negative? Okay. Well, we all have our identities sheet. This pink sheet. Okay. And so we would use numbers 1 and 2 on there. Okay? So sine of negative 2x would be negative sine of 2x. Right? So that would have a period of pi. Except it would go down. It would look like that because now we got a negative a value. Cosine of negative 1/2, according to my first identity, would be cosine of 1/2 x. According to trig identity number 1, because trig identity number 1 says cosine of negative t is equal to cosine of t. Why? We talked about that in the obviosities. Because when you go in a negative angle, the cosine stays the same because you're still on the positive side of from the start. And this would give me a period of 4 pi. Now, you may be asking yourself, how can Linz come up with these periods so quickly? Well, if you notice with all of these, there's a pattern. You might not see it right away, but you'll see it right now. Okay? The period is found, and you should definitely write this down. Okay? The period is found by taking 2 pi and dividing it by b. Okay? So the period is 2 pi over b.
Did you say that again?
The period is 2 pi divided by b. I'll show you. Let's go back a slide. So if we go back down here to these that we just found, my b value in number 1 is what? 2. What's 2 pi divided by 2? Pi. There's my period. In number 2, it's 1/3. What's 2 divided, or 2 pi I should say, divided by 1/3? 6 pi. 2 pi divided by 3 is 2 pi over 3. 2 pi divided by 4 is 2 over 4, which reduces to 1/2, so it's pi over 2. 1/5 dividing by 1/5, multiply by 5. 2 pi times 5 is 10 pi, and so on and so forth. Okay? It's the best way to find the period. You take that b, factor it out, and you've got what you have. Okay? So let's do one here. Okay? So let's do the sine of 2x. We want to sketch it. I gotta move these around here first. These are all, oh, no, of course they're not. Why would they? I mean, why? Why would we put them? Alright. Answer the easy one first. What's the domain of this function? All real numbers. Love it. Give me another one that we know. Based off of yesterday. Hint, hint.
Middle is 0.
Middle is 0. Give me another one that we know. Onliners, if you want to jump in here, give me one that we know. This would be a good opportunity. Unmute yourself and say a number.
Isn't the high 2 and the low negative 2?
Nope.
No.
What? What's 1? The high is 1, yes. Give me another one. Okay. Okay. Why can you say that with confidence? Why can we say that with confidence? But how do we know the high and the low is 1? Logan thought it was 2, and she was wrong. Well, that was like 2 minutes ago. What did we talk about yesterday? The amplitude is 1 because the coefficient out in front of the sign is 1, right? Yep, so the amplitude is 1, so we can say all of that based off of the amplitude being 1. No, because the amplitude is 1. All right? So, now, we need to first, before we figure out the start and the end, we first need to find the period. The period is going to be equal to 2 pi divided by b. My b value is this number here, so it is 2. So my period is pi. So the period here is just pi. So if we start at 0, where are we going to end now? At pi, not at 2 pi. Now we're going to end at pi. Okay? So, sine curve, regular, middle, up, down, middle. Right? Vertically, we go from +1 all the way down to -1, with 0 being in the middle. Horizontally, we start at 0, correct? Where do we end? We end at pi now. So what's halfway? Pi over 2. What's halfway to pi over 2? Pi over 4. What's halfway between pi over 2 and pi? 3 pi over 4. Okay? Those middle 3 are just averages. Okay? So you're just averaging the two ends. It's midpoints, really, is what it is. Okay? And a midpoint is an average. And there's our sketch. Okay? With that being said, I would like you to now do the exact same thing, but for cosine of 1/3 of x. So domain is going to be all real numbers. Amplitude is, middle is, which means my high value is low value. Range is -1 to 1 then. Okay. Love it. Period. What's my period? 6 pi. Where do I start? So where would I end? Cosine starts up, moves down, and back up. Right? Vertically, 1, -1, and 0. Agree? Horizontally, 0, 6 pi. Halfway would be 3 pi. Halfway would be 3 pi over 2. And my other halfway, 9 pi over 2? Yep, because you add them together and divide by 2, right? Shabam. 100%? Love it. One more. Let's do that one. Domain. Amplitude. Middle. would give me highs of 1, lows of -1, range from -1 to +1. Okay? If I were to use my trig identities sheet, number 2, trig identity says that this negative sign right here gets to go out in front. So this is really y equals negative sine of 1/2 x is the function that I'm dealing with. My period then would be 2 pi divided by 1/2, which is going to be 4 pi. Negative sign starts middle, down, up, middle. That's 0. Started at 0, ended at 4 pi, halfway. Halfway, other halfway. Oh, it was easy. Easy sauce on that one. Agree? Love it. In class, if you get out your Spaghetti Lab packets yesterday, I told you yesterday that you would have there was a mistake in the copying, and these 3 didn't get copied onto that worksheet. The second page of the worksheet. For those of you at home, we're talking about pages 3 and 4 really of the 4.4 worksheet. If you were in person last week, this is only applies to Group B people. If you were in person last week and got the worksheet, if you're printing off at home, they're all good. So the first one is y equals 3 sine of 2x, then plus 2, y equals negative sine of x plus pi over 3, then plus 3, and lastly y equals 2 cosine of 1/4 x, oops, that's minus pi, then plus 3, and that one comes with a hint of factor out the b value to make it look like number 5. Okay? That's all I got for you. Thanks for playing along. There will be 1, maybe 2, we haven't decided yet, videos for tomorrow for you guys that are online to watch. But we haven't decided yet. We're still kind of tweaking the schedule for tomorrow. So just check in tomorrow morning and you'll see what you have to do. All right? Thanks for playing along.